Okay, Assalamualaikum and hi everybody. I am Nur Azira Umaira. Okay, today I would like to share with you about lab 3 power factor correction with my partner Nurul Husna. Okay, first we must add the bus one. Work, click for bus. We set as 16K kilovolt and select the system select bus. If we rotate the bus one, here. Okay, next we add the bus 2 and have a same step at bus 1 just now. Have a same value, 16 kilovolt. Okay, next we must add generator at bus 1. Generator. And we must add the value, this value, 100 kilowatt and rated power at 75 kilowatt. Okay, but we use megawatt for this application. 100 and 75. Okay, we just connect at bus 1. Okay, next we add the transmission line. Okay, but we need to neglect the impedance value as just mentioned at lab sheet. We must neglect the impedance value. So we set here as 0. And for limit A, we set for 200 because of we use megawatt just now. So 200. For limit B, 100. Limit C, 100. Okay. Next, double click at plus 1. Right click at plus 1. And add new field around bus. Click at post 6. And set bus kilovolt. Okay. And we must do the same thing at bus 2. Right click, add new field around bus, post 6, and bus voltage. Okay, next, we must add load by the given from lab sheet. Sorry, load. For load, we set at 100 kilowatt and 75 kVAR. So we use 100 megawatt and 75 megawatt. Okay, then we click on, we double click on the load and we set the digit right of decimal to delta delta as 1.0. Then we must add the shunt, switch shunt. It be set as number of step at 10 and kVAR per step at 20. So discrete set at 10 per step is 20. Okay. Okay, next, right click on, sorry, just say decimal and 2, 1.0, and we right click on one line at anywhere and we click on one line display option. We go to animated flows and we set size and density as 30. And this one 20. Okay, we try to run. Okay, for display the arrow of blue, we must get the same of with figure. So we display the arrow blue of arrow. We go to one line, option, sorry, animation, blue, and we click at actual megawatt and megawatt. So here we got. So we try to run. Okay, this is our initial condition. The reactive compensation is at 0 MVAR. The value of reactive power and real power is at 75 MVAR. Okay, after that, we increase the reactive compensation to 20 MVAR. The reactive power flow from the generator will decrease and slower, just like we can see from this simulation. And the capacitor will produce the reactive power to the load. Okay, next, Husna will explain for the rest.
Okay, so for my part, I will explain when we increase the capacitor to 40 MVAR. Okay, so as we can see, when we change to 40 MVAR, we can see that the reactive power at generator will decrease to 35 MVAR. From the previously, as Umairah said, show that when we put the 20 MVAR at the capacitor, we get the reactive power generator to 55 MVAR. So from that, we can see that when the reactive composition when reactive composition increase, the power flow in our system and reactive power at generator will decrease. Okay, so for next part, we will see the calculation part. Okay, so when we reactive power is 20 MVAR, at the generator, we can see that P equal to 100 megawatt and Q equal to 55 megawatt. From the equation S equal to P plus JQ, and we put the value for P and Q, we get S equal to 114.13 angle 28.8 degree. Okay, from the angle, we put it in power factor calculation. So, power factor equal to cos 28.8 degrees. So we get power factor for reactive power in 20 megawatt, we get 0.8763. While for reactive power 40 megawatt, we get at the generator P equal to 100 megawatt and Q equal to 35 megawatt. So we put the P and Q in the equation and we get S equal to 105.95 angle 90.38 degree. So we put the angle in the power factor calculation. So for the power factor for reactive power in 40 megawatt, we get 0.9438. So from calculation, we can see that the power factor value become closer to 1, which 1 is the ideal power factor. That's all from us. Thank you.